Right, we're now into section 8.2, sorry. We just finished 8.1, but we want to revisit 8.1's counting principles. We had two of them. And they are multiplication, and this multiplication rule said you find the cardinality, it has to have two or more sets of finite number. In other words, you can count how many numbers are in there. It's not all numbers greater than 3. It is specifically 4, 5, and 6, like that. Okay, so set with finite numbers. Then it is the cardinality of the set 1 times the cardinality of the set 2, ... till we get to the last number that you have in the set, because you can have 2 or more, and that'll give it to you. It's just multiplication rule. Then we have the big one, permutation. The key part is only one set of elements. Again, they're finite, and the requirement is the arrangement count is order specific. This order specific is the key. And what we learned under permutation is we could use a factorial. In other words, whatever number we have, the factorial of it. And this asterisk makes it a factorial, meaning to multiply n times n minus 1, because it's one number less than n, and then n minus 2, ... till we get to only 1. And that means you multiply all descending numbers starting with the first one. It is always a whole number. Or I should say natural number. Okay, so then from that, and again, those are number of arrangements of order specific for the entire set use. Okay, so the factorial does that. But then you can have this guy here, the permutation, which is, I'm going to put my glove because I keep on opening things. Tablets are very sensitive. Then we have this one, NPR. The book uses it as P of NR. but for our calculator use, this is the construction. All right, so here we go. On this one, the n is the cardinal number of numbers. Cardinal of the elements in the set, and R is the size, and it's a subset of the size of the arrangements. Wanted. All right. Again, order specific. All right. So now we're getting into a third counting. Principle. This third one is called combinations or groupings. So it is like a team or committee, or all of those cases are what we imply by groupings, where there is no hierarchy. All right, so a combination is one set of finite elements, just like the other permutations. And again, none of them have repetition unless we divide them out. The set of finite elements with n equaling cardinal number of set of elements, and R is the size of the group. It can be equal to n, but not less than n. I mean, greater than n. Sorry about that. All right. So what does the book say on combinations? The book says a combination is a set of R elements chosen from a set of n distinct elements where repetition of elements is not allowed, and the order of the elements is not important. Order, not important. If C of nr is a number of combinations of n elements taken R at a time, where R is less than or equal to n, then this is the math. Notice that in permutations, it was n factorial divided by n minus R factorial. And notice here we add another R here because we're saying whatever the size is, we're dividing by repetition of that possibility, R. So here's some other notations. Now, this is the one I use. C, and it would be N of C, NCR. That is our rule here. And I've seen all of those used for statistics. Okay. So let's understand it. All right, hold that thought. we're going to understand the concepts of combinations. All right. So in combinations, and then the contrast of permutations. Right. So, how would I do that, right? How would I explain to you the difference? Well, let's take a dog. If I combine D, O, G is a set, and I do a combination using all the letters, then I would only have 3 choose 3, and that would be one group. Whereas if I had dog here, I would have the dog, or the DGO, or then I would have the ODG. I would have the OGD, and then I could have the G, OGDGO, yes, GODGO. Okay, and I think I have them all, don't I? Because that would be, I'm missing some, aren't I? What am I missing? DOGDGO. Yes, and that would be what we have for that permutation of DOG. So let me look at that. So you can see the difference where if I have a combination, I would only have the one, because it wouldn't matter how a dog appears. I only have one. Impossible. On this one, I would have 6. Okay, all one set. And each has grouping, not order specific. And this is order specific. So now you see the differences, and we can move on. So we want to evaluate. For this guy, let's see first of doing it according to the rule. So the C of 10(5) is going to be the 10 factorial like before, and it's going to be n minus 5 factorial over 5 factorial. Okay. Oh, that's 10. I know you see 10. All right. So we're going to say, and that's going to be 5, 10 times 9 times 8 times 7 times 6 times 5 factorial over 5 factorial times 5 factorial. So this means that I would have this cancel that, and then I would have 10 times 9 times 8 times 7 times 6 divided by 5 times 4 times 3 times 2 times 1. All right. So the 5 will go into 10. 5 and the 2 will go into 10. The 3 will divide 9 3 times. The 4 will divide 8 twice. So we would have 6, 6, 6, all right, and 7. And I came up with a number of 352. Well, that's all good and well, and it's fun, but we need to do it by calculator. So in our calculator, we're going to enter the 10C5. Now that would be 10 on the home screen, then math, arrow over to PROB, and we're going to choose number 3, NCR, and enter. Then we're going to enter five and enter again. So let's do it by calculator. Here we go. Ten, math, PROB, we're going to do number 3 and enter 5 and enter. And we get 252. Look at there. 352. Sorry about that. Oh, I'm sorry. It's a 252. My glasses are better. Glad we checked. All righty then. So now we have that information. Now let's look at this guy. Oh, we had another one, sorry. We're doing, Q and Q. Because the numbers are the same, and the word is congruent, then only one grouping. Very good, class. We are good. Like dog. All right. So we want to do this one by calculator because it is yucky. And so I'm going to get it right here. And I'm going to enter first my 37 because this is 37C20. 37, math, PROB, number 3, and it's 20. And enter. And notice that this one is huge. And we have our first reference to scientific notation. In a calculator. All right. We have the E. So I'm going to write what I see. 1.59, Sorry. Look at how I wrote it. Not good. 1.59053. And then I'm going to put dots. And then I'll see an E to the 10. And that is what that means, exponential. So I'm going to say 1.59053 times 10 to the 10. Because it's a very huge number. All right, does everybody get? Okay. So we're going to look using a deck of cards at probability with what we have. In between, we're getting reacquainted with probability. So here we go. A deck of cards has 13 clubs, 13 spades, 13 hearts, and 13 diamonds. Okay, these guys, and let me do that. I think that's black. All right, here I go. So all of that adds up to 52 cards. All right, there are 26 black cards and 26 red cards. So when we talk about probability, then we know what we're saying. This set here is known as face cards. And there are 12 of those. And then these are the aces are numbers 1 through 10. 1 through 10. And there are 4 aces, 4 twos, 4 threes, 4 fours, 4 fives, 4 6. I'm sorry, 4 of 6s, and I wrote 6. All of these are 4 of each of them. So if you're asking for one singular card type, it all equals 52. Everything equals 52. All right, so let's do some probability. In how many ways, oh, and we're talking a hand. All right, so we have all the distinctions. So let's see what we've got. In how many ways can a hand of 5 spades be chosen from an ordinary deck? So, from an ordinary deck, how many spades? All right. So, in our spades, we have our N is 13 spades. And we want, in how many ways can a hand be chosen? Our R is 5. And these are groupings. All right, so I'm going to write it as 13, choose 5. Again, order is not important, just grouping. So the repetition is not involved. All right. $1,287. All right, so that's how many ways we can select that suit of spades. All right. 5 cards are drawn at random from an ordinary deck to form a hand in poker. in how many ways is it possible to get the following results? Here we go. Let's see where we are. And we've got and here we have how many ways is it possible to choose 4 3s? Okay. And we're talking 5 cards are chosen at random. And they want how many can we have that choose 4 3s? So we have 4 specific 3s choose 3. Oh, 4 times, and then we have 5 cards. So I have, now I'm going to have to do the, I'm going to do it over here. I'm going to do 52 minus the 4 is equal to 48. How many ways is it possible to choose 4 3s? Okay, so we got all the 3s times 48 choose 1, because these are all 5 cards. All right, so this would be a 1 times 48, and we would have 48 ways. To choose 4 3s. All right, and how many ways is it possible to choose no spades? No spades. All right, so this means remove the suit of spades from deck cards. All right, so this part right here would be 52 minus the 13, and that would give us 39, wouldn't it? So this is the this is going to be our n. And now they want us to choose no spade. So it's n is that, and r is still 5. So not a bad thing. 39, all cards that not spades, choose 5. All right, we have to do in the calculator. Let me clear that. And we're going to do 39, choose math, PROB, number 3, 5, and enter. It's a big number. 575, comma 767. 57. Sorry, I read that as a 6. Very good. All right. Now let's see the next one. In how many ways is it possible to choose exactly 2 spades? Okay. And in this case, we're saying 2 spades. There are the suit of spades is 13. The R is 2. And then we're going to need everything else involved. So that's 2 cards, and we need 3 more, right? So that would be rest of the cards. That 39, and we're going to choose, if they're doing 2 spades, then we're going to, R is 3, because we need 5 cards drawn. So let me get over here, make some room. So this part here is going to be 13, choose 2, because order is not important, to 39, choose 3. This and this make the 5 cards. And this makes the deck of cards, which is 52. All right. So now we stick it in the calculator. Because they said any 2 cards. Not a probability yet. All right, so here we go. I'm going to enter the 13 math, PROB, number 3, choose 2, side arrow, times 39 math, PROB, number 3, choose 3. Okay. And that's going to give us 712 842. Okay, now we're going to go to this guy. Again, we're looking at the cards. Now we've got the at least. At least is an interesting number. Meaning at least 2, meaning that we can have 2 or 3 or 4 or 5th places. And that means you can have that particular setup and others, at least. You can have more, but you can't have less than 2. Here we go. Right, here we go. And it's combination. So I'm going to do 2 first. So that would be in spades, it's 13, choose the 2, times the 39, choose the 3, because that takes care of only 2. Plus 13, choose 2, times, no, sorry, 3. It'd be 3 on this one, because we already did 2. Times 39, choose 2, plus 13, choose 4, because we're not 4, 4 spades, times 39, choose 1, because we're 4 and 1 make 5. All right. And 13 plus and 39 make 52. And then we're going to have this guy here. 13 choose 5 times 39 choose 0. All right, because a max spade hand would be 5. All right, so now we're going to do the math. And we'll structure it first. So the first one going to be, let me do it online here. I'm going to cancel that. And I'm going to enter 3 math, PROB, number 3, and 2 times. I'm going to put that. Oh, I don't want divide. What do I have? Okay. I'm gonna do this one, and then I'm gonna take a break because I've been talking to you for 36 minutes. That's a long time, and I'm getting careless with how I enter, so I'll stop after this one. Okay, so I'm gonna have 13 math prob choose 2. I'm gonna up arrow here times 39 math PROB number 3, and we're going to choose the 3. I want to enter. That is 71242. 712,842. And then I'm going to do the next one. I'm going to go back. Delete that. Second entry. And then I'm going to go backwards and change the 2 to the 3 and the 3 to a 2. Enter. Oh, I made it 32. Sorry. Let's delete that. Okay, and I did that. And that would be, clear it. 712,4. Nope, I got the one above it. Sorry about that. Let me clear it. I'll do it again. I told you I'm making a little bit crazy mistakes. I'm on this one. 13 math PROB. I'm going to do number 3 and do 3 up times, and then I'm going to do 39 math PROB number 3 and do 2. So I'm on the 3 and 2. Yes, got it. 211926. Great. All right, so I'm going to do second entry. I'm going to change the 3 to a 4. And change the C over here to a 1. And I got it. And I'm going to get 27,885. The last one, second entry to copy, and I'm going to change it to 5 and 0 on the other one. Enter, and I get 1887, right? Oh, it's 1287. Sorry about that. It looks like an 8 to me at the moment. All right, so these are the values I want to add up to get all of the at least there. 712.842 plus 211.926 plus, being careful, big numbers, 27.885 plus 1287. Oh, I'm sorry, 527. Seeing that one. Make the calculator bigger. So 1287. Yes. Good. Just making sure. So how many? 9, 953, 940. And there you have it. Thank you very much. I'll do the next one in just a minute. So we did a lot with combinations and the calculator. Make sure you practice, make appropriate notes, and maybe watch it again. I'll do part B in a minute.